This is the ELEGOO SATURN, a resin-based 3D printer. It's broke. It's broken, but I'm gonna show you how to fix it and how to win one of your own. Let's do it. A portion of this episode is sponsored by Nico Industries. Head to Nico Industries for printable props, armor, and more. There you are. Welcome back. Like I said, the ELEGOO SATURN right here is broken, and this happened when I was doing prints for the HoverWewd. There was a print where a certain side of the print was failing. So if you divided the screen into 3 sections, Section 1 was all good. Section 2 was fantastic. Section 3 was a big giant pile of goo. So we have options on how to fix this and ways to troubleshoot it. And I'm gonna show you how to do this just in case you may need to have these skills for when you fix your 3D printer. Let's do a quick little refresher on resin-based 3D printing, and specifically this one. You know, back in the days, it was SLA, which meant a laser kind of pew-pew-pewed around and cured resin as it pulled it from a pile of goo. This one, though, is using UV light through an LCD mask, which then allows the light to hit resin in certain patterns. So think of it this way. Imagine you have a flashlight and you have a piece of paper and you cut a hole in that piece of paper in a certain shape. And in a dark room, if you shine the flashlight through that piece of paper with that shaped hole that you made, it'll project on the wall. And that's essentially what a resin-based 3D printer, such as this, is doing. The UV light it's using is the flashlight. The LCD mask is actually the piece of paper that you've cut a shape out of, and your wall, well, we're not going to cover it in goo because the tank full of resin is the actual wall that you're projecting the images onto. Kind of neat, right? So in this specific case, the failure, since we see some parts of it working and some parts not working, we know that we need to look at the UV light and whether or not all the lights are firing. And we need to look at the LCD mask and see if the mask isn't forming the correct shape. And in order to do that, we get to take it apart. So step 1 in all this, you have to prepare your 3D printer. Take the hood off. I've pre-cleaned this, but if your resin printer is full of resin, you should, clean that out first. But once it's cleaned, take off the build plate and set it somewhere safe, and also the tank. Again, make sure there's no resin in it. Or if there is resin, you have a way of covering it and keeping it safe so that your kids don't play in it.
What are you doing?
Now, the Saturn is at the point where we can begin troubleshooting. And in order to troubleshoot, we have to verify the problem. Let me get power, and I'll show you. You got the touch. You got the power. What I'm going to do is initiate a test pattern. That's going to create essentially a rectangle shape with the LCD, and it's going to fire all the lights. And the default time is 15 seconds, which is enough for us to verify. Once I hit that, though, you're going to see what I see, and that is a shadow on the right side because something isn't right. You see that shadow there, right over there on that side? So I can kind of see some light peeking through, and I can see the LCD mask making the shape, but it looks like the UV light on that side isn't sufficient. So my initial guess is that we have a failure with one of the lights. And I know that inside the Saturn, there are a bunch of UV lights. So let's find out how many segments there are and see if a segment is out, if the entire thing is out. Again, we're troubleshooting. We are going to take it apart, so it's important to turn it off and pull the power because you don't want to get shocked. For this part, you're going to need a 2mm hex key. I've got mine. This was a set on Amazon that someone recommended to me. It's from WERA, and it's the Hex Plus. I'll put a link down in the description. It has colorful handles that are easy to grip. I like it. Hashtag not sponsored. On the side here, there's a panel that lets you access the insides, and there's 1, 2, 3, 4 screws. You're going to want to take those out. One thing to note, these are all the same size screw, so you don't have to keep each of the corners separate. All of these screws will actually go into all of the holes. Another thing to note, while my model might not be the same as the one you have, we believe it's pre-production. So then there could be differences in here that you don't get to see, but any advice I give you is going to at least carry with it some general information that will work no matter the machine you're working on. I'm gonna set the screws right there out of the way, and then this part, I'm just gonna stick this end in and pull it off. With that side panel off, we can see that the USB connection is right here, but we also see 1, 2, and 3 connections. So my guess is the UV light matrix in here is 3 segments. So in order to test, what we need to do is find out which segment from the lights corresponds with which one here. That should be pretty easy to do. So what I'm gonna do, we're gonna start at the top, this one right here, and I'm gonna remove the bottom 2. So with that, I know that there's 1 connection, and if it's completely dark, then we know that this is either the bad section or the bad light. But if we have other lights, then we do other combinations of the plugs and the receivers in order to verify which one is there. Let's have a test. The side is open, but those plugs are fine, and you are safe to connect it to power at this point to do your testing. We're starting the test now. From my angle, what I see is an LCD matrix that is making the correct shape, but I see 0 lights. And I'm sure you're seeing 0 lights as well.
There are 4 lights!
So we know we've gotten the correct wires. We have the correct plug and we have the correct driver. Now we need to see what's going on with what. So for our first troubleshooting step for this part, what we're gonna do is we're gonna take this plug and move it down, and we're gonna verify if the light shines or not. Okay, from my vantage point, I see an LCD in the correct shape, and I see a light on the far third of the screen. This is fantastic news. I'm really, really excited about this, and here's why. What we've just done is verify that the light that wasn't shining before shines now, and we hooked it up to a separate driver. And so by process of elimination, it means that that driver isn't working correctly. I mean, and we can verify in order to double check ourselves by plugging in one of the other 2 UV light sources to that and seeing if it works. And just for the sake of completeness, let's do it. So at this point, we should see no change compared to what we showed before. Let's see if we're right. All the beeps. Here we go. We should see an LCD mask in the correct shape, and we see one of the 3 light sources working. This confirms our theory that the driver at the very top isn't working properly. This is fantastic news. Now that we know what the problem is, we can communicate with ELEGOO, tell them what the problem is, and rather than having to send a printer away to get fixed, all ELEGOO has to do is send us new parts. Ready? ELEGOO! Whoa! That was quick. Oh, look at that. It's a box. It's a special delivery from ELEGOO with a smiley face, and it says, "To 3D printing nerd." They must have heard my call. We now have a new part in. Let's take a look and see what it is, because I'm kind of excited here. You ready? Let's open it together. We've got new connectors here. And look at that. That's a new board right there. So it looks like we got a new board from ELEGOO. Thanks for that speedy delivery and almost taking my head off with it. The intent was good. You almost maimed me, but you know what? I love you anyway. Here we've got a new board, and it's kind of cool to see how this works. We've got 1, 2, and 3 plugs right here. My guess is those are driving the 1, 2, and 3 light sources within the Saturn, and we have 1 plug right here. And if I turn this over, right here, it says VIN. And for electronics, that, my guess, means voltage in. So this is the power source, and these are what power the lights, and here's all the driver circuitry. So now what we need to do is open this up, take the old one out, and put the new one in. This should be fun. I'm gonna put this back in its bag. We got some screws to remove. And there are 1, 2, 3, 4, 5, 6, and 7 screws on the top. Let me take those out, and we'll take a peek inside.
A few moments later.
Anytime you're doing something like this, because we don't know exactly how the inside is configured, you want to take it slow. If there are wires connected that you could accidentally pull out, there's a chance you might not be able to put them back, which means you need to get more parts, and that's not what we want to do. Take it slow, just like this. Ready? Inside, I can see the light sources, and it looks like I've got a piece of flat cable here that goes down to the board. I've got a motor cable, and I bet that's for the end stop right there. So I'm going to disconnect those so I can fully remove the top. It'll make it easier to get inside. You could lean this on something like a small child if you wanted to, but then you run the risk of putting tension on things that shouldn't have tension, and then you run into the further risk of breaking things. And so let's try not to do that. Here we go. And this one is a little tough. So this flat one goes right here. I don't know if you can see it. There's a small black tab that you can lift up, and that frees the cable. I'm going to try to use a fingernail. There we go. You could also use a non-metallic object. They make plenty of these for doing electronics exploration, but the fingernail was able to get it. This is free, and it means the top can safely be put aside. Having a look inside, there's this board. So this is the board where all the connections are, but then there's this metal piece, and I see a screw right here, which means that there's 2 screws right here that hold that in place. Let's take it out. Here's the board, and I noticed some very interesting things. This is the side right here that we were playing with, and that's why we have one of the light sources disconnected. But look on this side. 1, 2, 3. So with mine being pre-production or different than yours, it doesn't match up with this board. Let's compare them side by side. One thing to remember too, anytime you're dealing with electronics, make sure you are taking static electricity precautions. And so in this studio here, there is very little static, if any, and I'm not standing on carpet. If I was standing on carpet and generating a static charge, there is a chance that I could then take that charge and arc it into the board somewhere, and it could possibly damage things.
Now you're charged.
If you do have to do this on a carpet, just make sure you're holding on to the metal frame while touching any of the boards, and you should be fine. So here's the original boards, and there's 3 of them. There's a single board right now. A lot of the components look similar, if not the same, but it looks like everything has been simplified. Rather than 3 different power inputs, there's a single power input, and these 3 plugs right here power the 3 light sources. They are a different color, but that doesn't mean anything in this case. It just so happens that these are peach, orange, and those are greenish. So we should be free to connect these 3 up right here. Now let's take a look at the power cables, because if it only requires 1, let's take a look at how these cables are coming from the board and if we can take 2 of them away. So here's something that's really interesting, and it looks like it was first in an iteration. And so while the previous one takes 1 power input, this took 3, but they all come from the same wire. And if I trace this wire back to the board, it's a single wire. At this point, what we can do is disconnect these 3 power sources, and we just need to use 1. And what we can do, these are safe in the way that these are looking here, but we can just wrap them up with some tape just to make sure. I'm not too worried about that. The light sources themselves, they are not specific. There is no specific power driver per light source. It's all coming from the same. And so once we disconnect these, we now know that there's no order in which the lights need to be put back into the board. Have a look inside though. It's really simple what's going on here. Again, this is your flashlight, essentially, and the LCD mask over there is your piece of paper. And again, the tank is the wall that you're projecting the light onto. And it doesn't take much to drive that. How awesome is that? So here's the plan of attack. You can tell that there are 2 screws per board and there are 3 boards, whereas now we have 1 board. We're gonna take all the screws out and all the boards off. We're going to then put this board on. One thing we have to look out for are standoffs. Those are the metal pieces that come up from this piece in order for the screw to hold it in place but off the board. We need to make sure that these metal standoffs don't interfere with anywhere on this board. So let's get to it.
Eventually.
We're at the point where I want to attach this, but there's electrical contacts here. And if I put this board right here, then those are getting really, really close to that standoff. I've come up with a solution. It's not, in my eyes, the best solution, but it's what we can use with minimal amount of risk. I have this Gorilla tape, and this tape is thick, and if I put a couple layers on this board, it will guard against these points here contacting the metal here. If we look at one of the previous boards, they've got nothing poking through on the other side, so it was easy to mount here with these standoffs. These standoffs do get in the way right here, And these, while they don't connect, yeah, they're pretty close. And putting some tape down would make me more comfortable. Obviously, a better solution might be some thin foam with a sticky back you could put on there. It came with foam, but it's a little bit too thick. This part doesn't get hot in the machine. The fans in here are for cooling down the light array. So I'm not too worried about heat, but this tape with the stickiness will stay here and it should provide a decent amount of protection. Plus, one of the things that we have to consider, this isn't like in a car or a plane or a boat or something moving, right? This is a stationary object, and so there's a really good chance that once we put it in place, it's not going anywhere. I know that tape isn't the best solution, but it's a solution that we can use with an adequate amount of confidence. Let's just do it.
Later.
Now it's time to put it on. We've got the tape on the back, and that should provide adequate insulation, and I'm confident in this solution. One of the things we have to consider though, when this was in the printer like this, the previous boards had inputs on this side and outputs on this side. This has inputs and outputs all on the same side. If you look inside here, you have all the wiring coming from one side. So we might be in a bit of luck here, because if I face this board in this direction, all of the plugs are coming from this side, which means that I'm not having to route wires around things in order to not cast a shadow from the light source here. So I think that's what I'm gonna do, and we'll know if it works here in just a moment. This is our power. There's 3 from 1 on positive, 1 on negative. And so we just need to use one of these, and I can wrap some tape around these just to keep them from dangling too much. And we will put that into the voltage in right there. These are for the 3 different UV lights, and again, order is not specific, so they can be plugged in to any of the 3 spots here on the board. So inside, we don't have as much room to play around with the wires, but let's see what we can tuck, and then we will attach the bracket, and then we'll put everything back together, and then I'm gonna get these screws back on, and then I think what we might have to do is start a print. What do you say?
Yes!
Anytime you've taken apart a machine like this, whether it's a resin-based 3D printer or an FDM-style 3D printer or whatever, it's always good to recalibrate and re-level things. And so what I'm gonna do is loosen this up, and I'll re-level the plate. I'm gonna put in some Ceratec Fast Gray, and we're gonna print something. We're gonna print 3 things all at the same time, 1 thing per light source, essentially. I will get a plate full of fun stuff, and we're gonna get it to print. It's just gonna take a few hours, and then I'm gonna go have dinner. And Sean's gonna have dinner. And then we're gonna come back, take a look at it. We're gonna look at the results, and then I'm gonna tell you how you can win this Saturn 3D printer. I'm not even kidding. We'll see you in a bit.
12 o'clock midnight.
We're back, dinner is done, prints are done, and from just looking at it, they look perfect, right? I had a little security camera, was monitoring it, but let's get a closer look. Look at that. 3 lattice benchy boats printed in the Ceratec Fast Gray resin. I use this because, well, I like it, and it's probably one of the easiest resins to print with I've ever tried. Let's see, so in this orientation, the light that was bad was on this side, and it would mean this benchy would have been the one that failed, but if you look, all of the benchies turned out good. In fact, they're all exactly the same, and that's our goal, was to have an even light source across the entirety of the build surface. And we seem to have done that. These benchies look great. I mean, I'll get them cleaned up and displayed, of course. Maybe I'll hide them around town, but for now, I think we verified that they look okay. But Joel, I told you might be able to win this printer, right? Well, let me grab something. What's this? Another Saturn 3D printer? You may have seen other people on YouTube or other enthusiasts with these custom front panels on their Saturn 3D printers. ELEGOO did something nice for a bunch of people in the community and sent them customized Saturn 3D printers. I mean, it's really cool. It says 3D Printing Nerd. That's me. I'm now in a predicament though, because I now have 2 Saturn 3D printers. I can't speak for others, but I definitely do not need 2 Saturn 3D printers. And so while I say you could win this one, well, here's what I mean. When I said this 3D printer, I pointed to the hood. See? And besides, I fixed this one. It's personal to me. I would rather keep it, so it makes sense to say 3D printing nerd on it because I've had a hand in making it work better. This one, not only does it not have my handiwork in it, it's brand new. It just has a well-loved hood. So this is the 3D printer that you are going to enter to win, and it's free to enter. All you need to do is leave a comment on this video telling me what you would print if you won this. The contest is going to run for 2 weeks, and I'll announce it here on YouTube, well, on Twitter and Instagram, you know, wherever I post. I will announce the winner there, and then once it's claimed, we'll get this shipped off to you free of charge. The contest is open worldwide because that's the way it should be. Well, look at that. We are at the end of an incredibly successful episode. I took you through step by step on how you could fix a 3D printer thanks to new parts when other parts fail. I also showed you a new gift from ELEGOO that was actually kind, but it presented a problem which we fixed. And now you have a chance at owning a Saturn 3D printer free of charge anywhere in the world. And honestly, thanks for stopping by. Thanks for watching. If you made it this far, you're awesome. I hope you learned something. Practice kindness aggressively. And as always, high five.
You said you used gray because you just had the settings for it, right?
Oh, because I'd printed with it before.
Okay, yeah.
And so, because the white...
So the white's going to have a different cure time?
Yeah, because white is a different pigment, which means it's going to absorb the wavelengths differently. Yeah.
Sure. Okay.
Which is why clear also absorbs it differently. Clear needs more time because there's less pigment to absorb the light.
I gotcha.
And so that's why the clear sculpt required almost, 2.5, 3 seconds to cure, whereas the white sculpt ultra only required 2.
Okay, so that's interesting because I assumed because it was the whatever property that made it more resistant to heat, I thought that was the cause of the different cure time.
Oh, I see.
But it was the pigment?
Yeah. So just the different color, just like
Makes sense, but...
black PLA prints different than white PLA,
Yeah.
just because of the pigmentation.
Sure. Okay.
But it's different because it's not absorbing light. But I mean, you understand.
Yeah.
So I mean, like the cure times are going to be very similar, but for perfectly dialed in prints, you're going to do tests to make sure that cure times are appropriate.
Okay.
Yeah.